Another evening in the shop. I'm doing a batch of wooden screws. Figured I'd show you guys how I do a couple of things. I'll probably do a few more videos on the wooden screw making process here pretty soon, but that's further on the list of what I want to get recorded, and it takes me forever to edit videos, so who knows when I'll get to it. But in the meantime, I'll show you one of the ways you can easily tap a nut yourself if you're making a wooden screw. So this is one of my wooden screws. I've got a 45-degree pitch, 90 degree rather than your standard 60 degree that you would find on a metal screw. This one's an 18-inch long. This is either 18 or 19 inches long. Garter slot, 1-inch handle hole. This one's ash. 2 1/4 diameter, 2 threads per inch. And as you can see in here, there's your wooden thread on the inside. Now, you can hand carve a wooden screw pretty easily. Hand carving a wooden screw, there's a ton of ways to do it, and I'll show you guys in the future. I'll show you guys how to do a couple of the different ways to do them. Obviously, you're going to need a lathe or order some round stock for your dowels. So that's the basics of the wooden screws. Let me set this one aside. This is just one that I plan on putting on one of the benches here. So go ahead and make yourself a wooden screw. Alright. If you make it a little long, you can put a metal cutter in it. If you put a metal cutter out towards the end, you can drill a hole with your outside diameter in a blank, and you can put some dowels with some points on them to act as temporary threads. If you do that, then you can use that with that cutter to advance at the same pitch as your wooden screw through a nut. Now you'll have to, this is basically, if you're familiar with metalworking, this is single point internal threading. The only difference is, instead of the workpiece rotating, you're actually rotating the cutter at a 2 threads per inch or whatever your wooden screw, and actually it doesn't matter what it is, because whatever it is, it's going to match. You could make this an 8-inch wooden screw with a big old cutter on there, or a really fine cutter, and do the same thing. It doesn't matter, as long as that relationship is there. Since this is a one-to-one relationship, you're good to go. All you need to do is you need to figure out what the minor diameter is right here. Now you want a little bit of extra play, and while I wouldn't go with the hard dimension at an angle like this, you would normally on metal threads you would use some thread wires, or they make a micrometer that has one anvil and then a forked anvil here. And when you put that in, it goes, you know, it spans one of the peaks and goes in here, and that gives you your major and minor diameters there. But so you figure that minor diameter, and that's what you're going to want to drill your hole that you're going to tap for your nut. So what I've got is I've got my cutter. This is actually just a piece of 3/8 high-speed steel. It's actually a lathe, high-speed steel lathe tool blank that I ground to a 45-degree pitch to match this. I drilled a 3/8 inch hole, and then just used a float and a chisel, and I cut, you know, a little bit of the corners out to make it fit real nice and tight. I don't have a wedge or anything like that in here. I've tried wedges, I've used set screws, I've used a whole variety of methods, and I always come back to just a friction fit. I consider these disposable. I go through several of these a year. It's a little bit of a pain. I've made metal taps. They work as well, but I've never made one that I was real happy with. Eventually I'll get going on that again, but I don't have the power in my shop at the moment to run a metal lathe. After the move, I found out that I don't have enough power out here for the metal lathe, so that's just sitting, and I can't get to that yet. That is coming though, so metal working projects will be up on the channel eventually as well. But so let's say that this is your piece with your dowels in it. You're going to take a board and you're going to just make a little spacer, 1.5 inches. This is just 2x4s with a little cutout there. You just want enough to register here. Clamp it, you know, clamp that base plate down to your bench nice and solid and center that up. Then you can take your blank and set it on one side of those blocks. I'm going to move the camera here in a minute, and then you clamp these together. I'm going to go ahead and do that, but I'm going to move the camera first. Alright. So what I do, I gotta retract this a little bit. I've got a brass hammer, and so I've got the point here. I'm not hitting the point, I'm actually hitting part that never actually touches the wood at all. I don't want to dull that. Alright, so that's retracted. I need to retract it a little bit more. Let me get you a close up here. All right. There we go. So you can see that a little bit better there. It's just a piece of 3/8 high-speed steel, drilled all the way through, and that's where I adjust it. Make that a little bit shorter than your dimension here. So this is 2 inches here, So I made that just a hair under 2 inches. That leaves me a little bit of space. Alright. So I just barely start that through. Get it lined up, and then you just clamp them together. Alright, I gotta advance that cutter a little bit. I just have a little bit of a steel blank here that I use. I do not measure how much I'm advancing these. I do this pretty much by feel, and I check it against a wooden screw. I'm doing this in cherry, in this particular one. Cherry is a good choice for a wooden screw. I've had pretty good luck with it. Alright, so I've got that through once. And now we're going to advance that cutter just a little bit. And let me show you how I'm doing that. So right there, that's the butt end of the cutter. So I just advance it a little bit, and then just like that. And so you see right here, I've got that turned shaft where it's turned to the minor diameter of the screw. I can actually check whether I've got a good fit just by running that all the way through. So I know exactly when I can stop. Now, after you've done one or two of these, you get a feel for what's going to, what your tolerances are and what you can actually get away with tolerance-wise. You do need a much looser fit than you do with a steel or brass or aluminum screw. If you're getting this far into woodworking, then you probably already know that wood moves a lot more than most other materials. And if you don't know that by now, you need to start taking that into account on your work. Otherwise, all of your drawers and boxes and miters, glue joints, they're all gonna end up blowing apart. Okay, should be just about to the last pass here. Just a little bit more. Just a couple of thou. I might need one more pass after this, but You'll notice when you're doing this that when you get to the cross grain, you'll end up with a lot more resistance. If you've advanced your cutter too much, expect these clamps to work loose. If that happens, make sure you line everything up as nicely as possible before trying to do it again. Otherwise you're going to try and cross thread everything and ruin that internal thread. Alright, so I think that's just about enough. Let's see. That's still a little bit tight. It'll thread in there, but if it gets any more humid, that thread will seize up. So take a little bit more off. Tiny little adjustments are the way to go. Anything too big, you'll get a bind on that cross grain. And just like that. Alright, I'm going to pull that out and run a wooden screw through it. So there's all the little wood chips that come from the internal part of that thread. I don't know how well this is going to show up, but there's the internal thread right there. And let's see how a wooden screw fits through there. Here's one that hasn't even been finished yet. I haven't even sanded this one. And it's still a little bit tight. Not much, just a little bit. I shouldn't have to put that much effort in there. If you make just a standard nut here, you should be able to hit that nut on one side and it should freely go up at least several threads with no problem. If it doesn't do that, you made it too tight, and as soon as the humidity changes, either your nut's gonna shrink or your screw's gonna swell and it'll bind up and you'll have problems. So I'm gonna have to make one more little pass through there. So here's that screw. Here's the nut we just tapped. I went ahead and cut it off. And that's good fit. There should be a little bit of side to side play. Once again, and I can't stress this enough, if you're doing this, make sure there's a little bit of play. And the thicker your nut is, the less play there will be, but you should be able to feel a little bit of movement, because if you don't, that's going to bind. Well, that's how you do the internal threads on one of the screws. One last thing, I'm going to pull a couple of other taps over here and I'll show them to you. So one last thing before I go. Remember I said that these were kind of disposable? Here's one I made with a pad and a set screw. And see how it's split right here? Let's see if I can focus a little bit better. There we go. And then wood chips would get right in here. That's probably why it's split. So they work for a while, and then something happens. I've turned these down before, and I've put a metal collar on there. These have a series of cutter, almost like a metalworking tap. This is actually a set. This finishes, and this is the roughing tap. I can do this without this whole setup. I just drill a hole and then tap it just like you would a wooden or a metal. Like if you drilled a hole in a piece of aluminum and needed to tap it for $1/4 or something, it's the same idea. This is the one we just used. This was a metal tap that I made. I think this is 3 threads per inch, I think this is 1 3/4 inch. This is a big chunk of metal. This is a metal tap. It's a 6 flute. It works for the two, for my standard screws. I've got a hard time keeping it straight up and down, and I haven't found a good way to keep it nice and parallel or perpendicular. So it's always kind of off at a little bit of an angle. I can, no matter how I start it, it always kicks over just a little bit. So once I get the metal working equipment, I'll end up remaking this tap here. But as you can see, that's a hefty chunk of steel right there. I think that just about finishes it up. Hope you learned something. If not, hope you at least enjoyed it. Have fun in your own shop, and see you guys again soon.